I shall. This is Mr. G Math coming at you live, 7202, September 1st, 2017. Go ahead, throw the pen. This lesson is understanding where a function is increasing and decreasing and understanding what we use the first derivative test for. So let's look to make sure that we understand the procedure we're doing. We're going to practice. It isn't a very long lesson. It connects to what we just did in 4.1. So, to see where a function is increasing or decreasing, and that's also going to be the first derivative test. First, we need to understand what the domain restrictions are. So if there's a domain restriction, we need to be aware of it. 2, we're going to find all the critical numbers. What does that mean? We learned that from 4.1. What are critical numbers? Endpoints and first derivative equal to 0 and solve, and first derivative where it's undefined. So where are the critical numbers? Ends, first derivative equal to 0 and solve, first derivative where is the x undefined. All right. 3, you're going to locate critical numbers and domain restrictions on a number line, and you're going to label that number line. You're going to test to see, using the derivative, whether it's positive or negative in between those intervals. Using the first derivative, if it's positive, that means it's increasing between those numbers. If you plug in a number and it's negative, it's going to mean it's decreasing between those numbers. And then, where are we at? Test the sign in each interval. That's what I said. Then we're going to list the intervals where it's increasing and decreasing and identify relative minimums and maximums. So what does that mean? If it changes from increasing to decreasing, you just identified a relative max. Tim Gertson here. Yes, thanks. All right, Raphael. That was all you on the video because you're leaving. So when you see this video, Raphael, you better be watching this video. This is all because of you why we have to have that disruption. Anyways, you're leaving. Go to the attendance office. Anyways, let me go back to the point that when you know when something's increasing and then changes to decreasing, you just found an x value of a relative maximum. And the other way, if it goes from decreasing to increasing, you just found where the relative minimum is. If the sign doesn't change, you didn't find a relative max or min. Okay? So the sign has to change or else it's not a relative max or min. You get what we're doing and practicing?
So if it's positive, it's max, and if it's negative, it's min.
No. So if it changes from positive to negative, it's a max. If it changes from negative to positive, it's a minimum. Let's practice. You ready? There you go. Roller coaster time. So, can we do number 1 together, please? Now, each question, there's a little bit of work. So, like for me, I'm going to draw a vertical line straight down to separate 1, 2, and 3. So let's start at number 1. It says, find the intervals. Mr. Nava, we're going to just try first. Let me teach you through it with the video. And then as you practice, Gardenia will have patience with you. Because I know Alyssa won't have patience. I think you're right talking to Gardenia. So, find the intervals. How do I find the intervals? It's finding the critical numbers, right? Now, when I look here, are there endpoints at all to this function? Is there a domain restriction that way? No. So we don't have to worry there. Instead, we're going to take the derivative first. So I need you to take the derivative of f of x. What rule are you going to do? The chain rule. So the exponent is 2/3. Inside is x squared subtract 9. Subtract 1. And the exponent is negative 1/3. And then what's the derivative of the base? 2x. Beautiful. To make it a little easier, we're going to write that as a fraction. Because when you write it as a fraction, it'll be easier to find the critical numbers. So can you tell me what goes in the numerator and what goes in the denominator?
2.
More than 2. Notice that 2/3, you have a 2, but what else do you have at the end? So when you multiply them together, you get 4x. Thank you. Can you see where that 4x came from? Do you see the 2 in the numerator? Do you see the 2x at the end? Let's pretend we multiply them together. Do you see where 4x comes from? I want to make sure Gardenia and me are like so on this. That's on what, right? The denominator. I don't know who's dinging, but that's on the video. The 3 is in the denominator.
Sorry.
And if you write this as a radical, you might understand in terms of understanding where it's undefined, right? That means the cube root of x squared minus 9.
Didn't you also write it over 1?
To write what over 1?
X squared minus 9, just put it over 1 or under 1? No.
I don't want to write it that way, no. I want to recognize it that as a fraction rather than as an exponent, and recognize the radical sign, understand the negative exponent, because when we look at here, what value of x will make this equal to 0? Because we're going to take the first derivative equal to 0. Once it's a fraction, all I have to look at is the numerator. The denominator has no effect, because 0 divided by anything is going to equal 0. So when I look at the numerator, and it's 4x only, equal to 0, what does x equal? Now, we have to be careful. Also, would that make it undefined? Well, if I plug 0 into the bottom, would that make the bottom 0? No. So what's one critical value on my number line? 0. Good. What would make the bottom undefined?
3.
So I want you to notice the denominator. If the denominator is 0, it's undefined. If I take what's under the cube root sign, x squared minus 9, what's under the cube root sign, if that's 0, everything's going to be 0, right? The 3 doesn't affect anything. The cube root is whatever. It's here. This part can't be what number? 0. So take x squared minus 9. Can you solve this? What do you do first? Add 9, and then what do you do? And you got to be careful, because the answer could be positive and negative 3. What we said is this. When you plug in 0 into the derivative, the answer is 0. Do you believe that? I'm going to say it again so you actually have body language. You believe it. What we just found are the critical numbers. When I plug in 0 for x, the first derivative is equal to 0. Yes or no? Good. When I plug in positive 3 for x, and we go 3 squared, take away 9, and do the arithmetic, it's undefined. Yes or no?
Yes.
When I plug in negative 3, and you go negative 3 squared and do the arithmetic, there's 0 in the denominator, makes it undefined. Do you believe those are your critical numbers?
Yes.
What makes it equal to 0 and what makes it undefined? We're going to draw a number line. There's no endpoints to the number line. It goes forever to the right and left. All I care here is we're doing a first derivative test. So when we want to know if it's positive or negative, where do we plug it into? The first derivative, okay? Not the function. What numbers do I put on my number line? The critical numbers, in order. That would be negative 3, then 0, then positive 3. Do you see putting them in order? Do you see the critical numbers we came up with? Now we need to plug in numbers in the interval to see if it's positive or negative, meaning the first derivative. So what's a number less than negative 3 that I can plug into here? The more we practice, the quicker it becomes to understand if the answer is positive or negative. I don't care what the actual number is. I care if the answer is positive or negative. You understand? So guess what number I'm going to plug in? Negative 4. Because it's a fraction, I'm going to say, is the top negative or positive? Is the bottom negative or positive? Put it together, we'll get the sign. Yes? So when you plug in negative 4, is the top negative or positive?
Negative.
Got that in your head? Plug negative 4 in the bottom. Negative 4 squared, positive, right? 16 take away 9. Positive, the cube root of something positive, 3 times whatever, positive. It's a negative divided by a positive. That would mean what? What did we just find? From negative infinity to negative 3, this function is decreasing. From negative infinity, right, to negative 3, this function is decreasing, right? Left to right, it's coming down. How about from negative 3 to 0? What's a number I can plug in? Negative 2, negative 1. Both are beautiful. Top, negative or positive?
Negative.
Bottom.
Positive. No, negative.
So if I went negative 2 squared, right, or negative 1 squared, right? Positive. But that number subtract 9 is going to be negative. And the cube root of a negative number stays negative. And a negative times 3 is going to be negative. It's a negative divided by a negative. So between negative 3 and 0, it's positive. What did we just find? Between x equals negative 3 and x equals 0 on the graph, that graph is increasing. All right, how about between 0 and 3? Pick a number.
1.
I love 1. I love 2. Plug it into the top. Positive or negative?
Positive.
Good. Plug it into the bottom.
Negative.
Beautiful. Positive divided by a negative.
Negative.
Plug in a number bigger than 3 and see if the derivative is positive or negative. It is, right? The top is positive and the bottom is positive. So the question is, can you tell me at what intervals is this function increasing?
Yeah.
It increases from where to where? Negative 3 to 0, and it increases from 3 to infinity. Can you tell me where this function is decreasing? Negative infinity to,
Negative 3.
and
0 to 3.
notice when I'm doing intervals like this, the ends are neither increasing nor decreasing, right? It's 0, right? It's a horizontal tangent. If I asked you, where is the relative, and they ask for points, what does that mean? I need an x value and a y value. So if I asked her, where's there a relative max? Do you remember where we find relative max? It changes from what to what? Increasing to decreasing. So do you see where it goes from positive to negative?
Yeah.
Where?
0.
Zero
just a point.
It's a point, right? So where's the only x value that goes from positive to negative? Only at what number?
0.
So there's only one relative max. It creates a little peak in the graph, right? Now if you plug that into the function, the original, what's the y coordinate? I'll let you think it. Can you take the cube root of 9? No. Is it irrational? Yes. You're just going to write it. Simple. So when you plug in 0, 0 squared is 0. What 0 take away 9 is? Into the function. I'm finding a point on the function. I'm not going to plug it into the derivative. So I know the x value is 0. When you plug it in, you're left with negative 9. Is there a number 3 times itself that equals 9? No. So you're just going to leave it irrational with a fractional exponent. All right. Do we have any relative minimums? Yes. How many? 2 of them. So at what x value do we have a relative minimum?
Negative 3 and 3.
So at negative 3 and at
3.
positive 3. Do you know when you plug in negative 3 and positive 3, it'll give you the same answer? Because when you square it, it'll end up being the same. Now, positive 3 and negative 3 squared is 9. 9 take away 9 is, and 0 to any exponent is going to be 0. What I wrote down are 2 points, right? Positive 3, 0 and negative 3, 0.
Kristen,
I'm listening.
how did you get the first 0 for the relative max and the 3 for the...
Okay, so how did I get the x coordinate to be 0? So I looked on my number line, Gardenia, and I'm looking for where does it change from positive to negative. So in other words, from increasing to decreasing. So at what x number did it change from positive to negative?
0.
That's where it came from. Is that good?
Yeah.
For the minimum, you're looking to see where did it change from negative to positive, decreasing to increasing. That creates a minimum. So at what x number did it go from negative to positive?
-3.
Good. At what x number did it go from negative to positive?
At 3.
And if you want to find a point, you have to take that x coordinate and plug it way back to the beginning, right? Into the function. Are we together? Now, you know the first time you do anything, you should be patient with yourself and want to practice more because you don't quite got it yet. Okay, let's look at number 2, and we're going to do the same work.
Wait, can we label where we did each step?
You can do whatever you want. You can have extra note sheets and staple it to this packet, or just have supplementary notes. I think that's a wonderful idea. Number 2. What do I do first?
Derivative.
Yay! This will be fun. What rule are we going to use?
The quotient rule.
Love it. What is it?
The bottom times the derivative of the top derivative of the bottom. Okay. The bottom.
I like that. You can lick a SpongeBob if you want.
He borrowed.
Like his bottom is cool.
Oh,
He doesn't wear
that's
pants.
funny. Yeah, he
does.
He wears shorts.
Okay. He maybe doesn't wear a shirt. So,
He wears like a scarf.
does he wear both? Maybe he's thinking when
Attached to his shorts, okay? And like the chin, I guess.
Okay.
It is something. Grover doesn't have pants.
Okay, we have to do some algebra before we do the calculus that we need to do. So let's do this together. 3 times 4. And add the exponents. We're going to distribute the 3. So it's going to be negative 3x to the 4th and negative 9. The denominator is going to be 9x squared. Take a moment, breathe through it. Can you see the algebra I did? I distributed. I was careful with the signs and everything. There are like terms on top. Do you see the like terms? 12 take away 3 is, how many x to the 4th do I have? 9. What is going to divide out here on the top and bottom? 9. And it's going to leave you with x to the 4th, subtract 1 over x squared. We're not done. How would you factor x to the 4th, subtract 1? That is a difference of squares. What's the square root of x to the 4th? And the square root of 1? So one's going to be x squared minus 1, and the other's going to be x squared plus 1. Stick with me.
Why is it like 10x squared? Why is it-
Isn't that x squared?
X squared subtract 1, x squared plus 1. The bottom is no 9. Thank you. Then, x squared subtract 1, we can factor further. X squared subtract 1 again is a difference of squares. So if I put this all together, I would have x plus 1 x minus 1, and if I continue here, it would be x squared plus 1, all over x squared. So all together, x plus 1, x minus 1, x squared plus 1, all over x squared. We did that work because now we don't need to solve equations. The answers we need are right there. Tell me the critical numbers for x. What makes the top 0? What makes the bottom 0? Negative 1, positive 1, and 0. Do you see that? Negative 1 makes the top 0. 0 makes the bottom 0. Positive 1 makes the top 0. So the zeros at the top and bottom. That's what makes it 0 and what makes it undefined. All right, where do I plug in to see if it's positive or negative? Now, if I was going to do it, I would go right here. They're all equivalent, right? But which is the easiest form to see if the answer is positive or negative? Can you see that? And an even exponent will always make it positive. Yes? So the denominator will always be positive, but the numerator might change. So if I plug in any number smaller than negative 1, if I plugged in negative 2, would that make the whole derivative positive or negative? Negative 2 to the 4 becomes a big positive number, right? 16. And 16 take away 1. And then the bottom will always be positive. So it's a positive divided by a positive. What did we just find? From negative infinity to negative 1, this function is increasing. Between negative 1 and 0, pick a number.
0.5.
Good. Negative a half, right? If I go here and I go negative a half to the 4th and subtract 1, altogether that's going to be what type of number? Negative. The bottom will always be positive. Negative divided by a positive. So what did we just find? From negative 1 to 0, it is decreasing. Okay, pick a number between 0 and 1. Positive a half. What's going to happen? The same thing. And at 1, what's going to happen? If you plug in a number bigger than 1. Positive. If I asked you, where is this function increasing? What intervals would you write down? It's increasing from negative infinity to 1, to negative 1, parentheses, and it's increasing from positive 1 to positive infinity. Decreasing from negative 1 to 0, and where is there a relative max? Where is there a relative minimum? So a relative max would be at what x value?
1.
Where? What happened?
Can you write those two?
Negative
That's
1.
Why can't you write this?
What's that?
From negative 1 to 1.
You know why? So I'm going to tell you. At x equals 0, something's happening. Look at the very beginning, the function. Is it defined at 0? Do you know what that would create on a graph? A vertical asymptote at 0. So that's why we go from 0 and then 0 to 1, because it's not continuous at 0. That's a great question, Candelario. Where is there a relative max? When it goes from positive to negative. So at what number? Negative 1. Go way back to the beginning. Plug in negative 1 and tell me the answer. Go way back, way back, way back. Negative 1 to the 4th plus 3 divided by negative 3. Beautiful. Negative 4 over 3. Where is there a relative minimum? 1 and positive 4 over 3, right? All right. I want you to take a moment. What I'm going to do, which is not going to be on the video, is I'm going to open up Desmos. You know what I'm going to do? I'm going to type it in so you can actually see where it's increasing and decreasing, then see that you actually found it with calculus, right? You remember way back a year ago? To find this, we had to have a graphing calculator to find these points, where they turn. You just did it with no calculator, right? You all are geniuses. So I'm going to type it in. All right, don't look at yourself. Here we go.
But I always like.
So I'm going to type in the function x to the 4th plus 3 over 3x. You, being a genius, without a calculator, found where it was increasing, decreasing, and the turning points. Now, obviously, you don't get Desmos. I would ask you to take out your calculator, but I don't want to waste the time right now for what we're doing. So, I'm going to type in x to the fourth. This is not a calculator lesson today, that's why. Plus 3 over 3x. Oh, what is this thing? Okay, can you see that graph? Can you see that you said, now look, I'm going to click on these turning points. Now, what did you tell me? From negative infinity to what x value? Negative 1, what was the graph doing? Increasing. True or false? From negative 1 to 0, what's the graph doing? Decreasing. What created at negative 1? We found a relative maximum. And what's the y value there? Negative 1.3 repeating is the same as negative 4/3, right? See how smart you guys are without a calculator? There's no way a year ago, right? You'd have any chance at this. From 0 to positive 1, the graph is decreasing. And then from 1 to infinity, it is increasing. And then what's the relative min? 1 and 4/3. Do you see that? Do you see how smart you are? Right? No calculator, what you could do with calculus? Woo! We got one more to do. Yes, Juan?
You're the calculator.
I am a calculator. I'm better than a calculator. 3. There is no person pushing my buttons getting an answer. I got my own free will. 3. All right. Let's do this. And guess what? The first time you do something, you don't get it. Welcome to the real world. Welcome to college. The first time you see something and you still go, I don't get this yet. Right? Like, who are you that thinks that everything you do, you're going to learn in 30 seconds? That you don't have to work and practice and sweat and be frustrated and get help, right? Who do you think you are, right? To think that every time, everything you learn, it should take 1 minute or it's not worth it. Silliness. Welcome to the real world, right? It takes time to learn something. 3. What are we doing again? We're finding where it's increasing and decreasing. We're finding if there's relative max or mins. How do we do that? We find the critical points. Do a first derivative number test. You know when you draw a number line for the first derivative? That's called a first derivative test. Here we go. So what do I do first? Go for it. Yes, it's that easy. Second, what are we going to do? Equal to 0. I want you to solve that before I do it. Is there a way to reduce this down? Divide everything by 3? Keep going. What's a good way to solve a quadratic? Factor. 2 numbers that multiply to 1 add to 2. You can do this. All of you, right, can do this. And x minus 1 is the same as x minus 1 squared. Don't sweat. Guess what the answer is? Positive 1. That's what makes it 0. No other, right? Is there any x values that make it undefined? No. It's a polynomial. Smooth continuous. Nothing that makes it undefined. So there's only one critical number. At what? At where? Test it. Using the first derivative. What happens? What's an easy number to plug in that's less than 1? 0. Is the answer positive or negative? Beautiful. Into the derivative. Plug in a number bigger than 1. I would use, well, you can use either one. It doesn't matter. If you plug in 2, what happens? Pick a million. What's a million squared? Guess what it's going to be? Positive. So, where is it increasing? From negative infinity to positive. Why did I include it all, Conlery? Because at 1 it's defined, right? It's not an asymptote or anything, right? Decreasing. Doesn't exist, right? Never. Is there a relative maximum or minimum? No extrema. So why is there none? because it doesn't change from positive to negative, right? Or negative to positive. Now, if you read at the bottom, it says the function in example number 3 is called strictly monotonic. Do you know what Latin mono means? One. That means that it's either only increasing or only. So strictly increasing or strictly decreasing functions are called monotonic. So example 3 illustrates 2 important points. Not every critical number produces a relative or a max or a minimum, correct? A critical number, if the signs don't change, it's not a max or a min. And even though the slope at x equals 1 is 0, right, the function is still always increasing. We'll learn later in this unit what actually is happening there is called a point of inflection. So that, it means something different. The concavity changed, maybe, right? But there's no relative max or min. All right, that is the end of the lesson. Over and out.